Hello guys, welcome to another video. This one is paper 1 of the year 2013 for Add Math. This one is a specimen paper for that year. So again, this one is a requested question. So basically what I'm doing right now is I'm doing all the requests that I'm receiving on my comment sections for all my subscribers. Anyways, let's move on to question number 1. So this one is a sets questions, and since you guys will not be tested on sets anymore for Add Math, we can just skip this question. Let's move on to question number 2. So we have to find the set of values of x for which this is true. Okay, so step by step, as you can see, we have the square term on one side and a linear term on the other side. So let's just first expand the one on the left hand side. Let's see what happens. So here you will have 4x squared plus 4x plus 1. So when you expand this, you're supposed to get this. Now, let's say you don't know how to expand this. You can always rewrite this down as 2x plus 1 multiplied by 2x plus 1. So this is equal to this, and then you can just expand this step by step. You should be getting the same value as this. Now, more than, this will be 8x plus 9. Now, we can send everything to one side. Let's send everything to the left-hand side. You will have 4x squared plus 4x. Then we have minus 8 plus 1 minus 9 more than 0. Now simplify. You will have 4x squared minus 4x minus 8 more than 0. Now before we do anything else, we can try to see if you can simplify this equation. So if you observe, we have 4 here, and 8. We can divide everything by 4. Now, that will be x squared. That will be minus x minus 2 is more than 0. Okay, so now right now we have to try to find the values of x for which it is more. This equation will be more than 0. So we have done this question many times. As always, we first begin by trying to find the critical values. So let's see what you will have, okay? So the critical values for this one will be what? We have to first equate that equation. So basically, x squared minus x minus 2 equate to 0. So when you find the critical values, you just have to change this to equal. Okay, then you factorize. You will have x here, 2 is 2 times 1, so 2 times 1. To get minus 1, we have to have, so minus, this is 1, right? To get minus 1, we have to have minus 2 plus 1. So you will have the value of x to be minus 1 and the value to be 2. But now this is not your answer. This is the critical values. To find your answer, you have to go back to your graph. This is the line 0. And because the value here is 1, it is positive, you will have a shape like this, right? Now these 2 points here of intersection, these are called your critical values. That will be minus 1 and 2. Now our goal is for the equation to be more than 0. So more than 0 will be above the line 0 will be this side and this side. So we conclude x has to be less than minus 1 and has to be more than 2. So this will be the set of values of x for which this is more than this. That is question number 2. Okay, so let's move on to question number 3. So we have to prove the left hand side is equal to the right hand side. Now obviously if you want to, you can also prove the right hand side is equal to the left hand side, but that will be kind of tough. So let's just begin from the left hand side. Okay, so here we have as you can see, we have a fraction plus another fraction, right? Now because the base are different, we have to make it become the same so we can add them together. So to make it become the same, we can simply just multiply them by each other. You will have 1 plus cos A multiplied by sin A. Now next we have to cross multiply. That will be sin square A plus 1 plus cos A. But hey, we realize that these two are the same thing, so multiply become 1 plus cos A squared. Now let's simplify. So we can just expand this first. Let's see what happens. So here will be sin square A plus That will be 1 plus 2 cos square A minus, sorry, it's not cos square, so mistake here again. That will be 2 cos A, and that will be plus, no minus, so cos square A. That's the expansion for this one. Now divide. That will be sin A multiplied by 1 plus cos A. Oh, that was pretty foolish. Let's see what happens. So I think we can actually just simplify something else. But anyways, let's just proceed step by step and see what happens and what can we do. So simplify. You will have sin square A. Here we have plus cos square A. So as you guys must know by now, when you take this, when you add 2 cos square A, you have to have 1. So 1 plus 2 cos A. Okay, so that was actually perfect. We can do something very soon. If you observe, we have sin A, 1 plus cos A. Now, 1 plus 1 is 2. You have 2 plus 2 cos A over sin A, 1 plus cos A. Now, finally, what we can do is we can just factorize the 2 outside. You will have 1 plus cos A over sin A multiplied by 1 plus cos A. Okay, so these two, obviously, they will cancel out. You will have 2 over sin A, and that is equal to 2 times cosec A. This will be shown as required for question number 3. Okay, so let's move on to question number 4. A function f is defined by this. So when f of x is divided by this is the factor by which it is divided. The remainder is 3. Okay, when f of x is divided by this, the remainder is 6. Find the values of a and b. So pretty easy. Here we have to use the remainder theorem. So first thing is when it was divided by x minus 1. Now, what is the value of x? So we have to equate that to 0. So from this, x has to be equal to 1. So this means that when the function takes the value of 1, the remainder was equal to 3. Right? Now we just have to solve this equation. So replace x by 1 first. You will have a times 1 cube is 1, plus b times 1 cube is also 1, plus 3 plus 4 equal to 3. So a plus b has to be, so this will cancel out, you have minus 4. This is my equation number 1. Now let's use the other information here. It says when the function is divided by 2x plus 1, so 2x plus 1, same step, equate to 0. X will be minus 1 over 2. That will be f of minus 1 over 2 has to give you a remainder of 6. So again, we have another equation. So let's replace and see what happens. That will be a. That will be this cube. That will become minus 1 over 8 plus b, 1 over 4 minus 3 over 2 plus 4 has to be the value of 6. Now simplify. That will become minus a over 8 plus b over 4. And of course, you see, when you have fractions and everything, just use your calculator. It will be much easier than to think with your head. That will be this, and then we send this over here, 6 minus answer. That will be this, 3 1/2. Right. This is my equation number 2, but we can simplify. Because we have the denominator as 8, here we have 4. We can multiply everywhere by 8 just to eliminate the base. It is way easier to work with integers than with fractions, right? Let's do that. This will become minus a plus 2b. That will be what? So answer times 8, that will become 28. So let's try again. 3.5 times 8, 28. Right. So this is my equation number 2. Now let's make a become subject. From here, why not? So a will be equal to 2b minus 28. Now, as you can see, we have two equations we can solve simultaneously to find the values of a and b. First, we can replace the value of a here by this a. You will have 2b minus 28 plus b equal to minus 4. Right? This will become 2b plus b will be 3b, and that will be plus 24. From this, you will have b has to be the value of 8. And finally, replace back the value of b in here. You will have a has to be 2 times b minus 28. That will give you what? 16 minus 28, that will be minus 12. So a is minus 12, b will be 8. This will be your answer for question number 4. Now let's move on to question number 5. So here we have to solve the equation. So basically find the value of t, solving the equation. So first thing first, as you can see here, we have denominator of 7. So it is a fraction. It's kind of hard to work with fractions. So what do? Just multiply everywhere by the denominator. You will have 2t squared equal to 9t plus 5. It will just cancel out this one. Because if you think 5 over t times t, what happens? This will cancel out. That's what happened. Now next step, let's put everything to one side. You will have 2t squared minus 9t minus 5 is equal to 0. So let's factorize. So 2t squared will be 2t times t. 5 is 5 times 1, right? So to get minus 9, we have to have minus 10 and plus 1. So because 2t times minus 5 is minus 10, and then plus 1 times t will be plus t. So minus 10 plus 1t, that should be minus 9. So t will be minus half, and t will be 5. Okay, so now for part B, as you can see, hence. So whenever you see hence, you have to use the previous answer to try to find this question. We have to solve this equation. So if you observe, what happened here is, let me rewrite this down. This is 2x power half is equal to 9 plus 5. We can bring this down. This is negative here. If you bring this down, it becomes positive value. But if you observe, this looks a lot like my equation over here. The only difference is, here we have t, here we have x half. So basically, the same logic, if you were to solve this equation, eventually you will end up with the same answers. Just the only difference is t is equal to x power half in this equation. So basically we know that, hence, because of that, we know that, because of this replacement, x power half has to be minus 1 over 2, or x power half is equal to 5. Okay? Now let's move on to question number 6. So given that a is equal to this and b equal to this, these are two vectors, as you can see. Part 1, we have to find the unit vector in the direction of a. So pretty easy. Unit vector is equal to the vector a divided by its magnitude. That will be a is 5i minus 12j. And what is the magnitude of a? That is found by taking the first value, which is 5 squared plus 12 squared. That will be 169, and that will be 13. So 13 will be the base. So that will be 5 over 13 I minus 12 over 13j. This will be the unit vector in this direction. Now for part 2, we have to find the values of p and q such that this equation becomes true. So step by step, q is a constant, so q will be here. A is 5 minus 12. So again, when we express a vector, we can write 5i minus 12j. It is the same thing as 5 minus 12. So just to explain why did I write this, because I like working in this way. It makes my life easier. That's why I choose to work in this way. So it is your choice. You can always keep it the same way, or you can change it to this form to help you work with your question. Now, plus b. b is p plus 1. And that is equal to 19 minus 23. So basically we have to form equations and solve this equation. So expand, we have 5q plus p is equal to 19. That's my equation number 1. And we have minus 12q plus 1 is minus 23. So simplify. Minus 12q is minus 24. So q has to be the value of 2. Okay, so now we have to find the value of p. So p will be what? From the first equation is 19 minus 5q. So 19 minus 5 times 2 has to be 19 minus 10, and that will be 9. That is equation solved for question number 6. Now let's move on to question number 7. We have to express this one in terms of this, which is a complete square form, where a, b, and c are constants to be found. Okay, so let's see what can we do. So step number 1, because we have 4 here, we have to make this become 1. That's the first thing we need to do. Now, how can you do this? Step by step. Let's try. So we can take out the value of 4. You will have x squared minus 3x, and then we can just leave the 3 outside. No big deal, right? And then we can try to move on to the next step now. So that will be 4. Here we have x squared minus 3x. Leave some space for now, and plus 3. So here we have to add a value. The value you will have to choose is the value here. So we don't take the sign into account, just the value. The value is 3. Divide by 2 square. Okay. Now, so of course, when you add something, you also have to minus the same value, so your equation does not change. So that will be the value, but of course now it is inside the bracket. You will also have to give it the value of 4. Okay, so you have 4 x squared minus 3x plus 3 over 2 this plus 1. This will become what? Let's see. So we have expand, that will be 9 over 2. Sorry, 9 over 4 times 4. That will be 9. 3 minus 9, that will be minus 6. So that will be minus 6. Now if you try to factorize, you will have what? 4. X squared will become x. Here we have minus, that will be minus. And here we take the value inside, that will be 1.5. And that will be square minus 6. This will be the complete square form. But as you can see right now, it is in this form. So we can try to bring this in if you want to. So let's bring this in. So if you convert this, that will be what? 4 is also 2 square. That will be x minus 1.5 square minus 6. Now we can just factorize. You have 2 here. X minus 1.5 square, because they are both square, minus 6. So finally, find some space. That should be what? You bring the 2 inside, that will be 2x minus 3 square minus 6. Okay, this will be your answer for expressing this in this form. Okay, that will be question part 1. Now, in exams, if you're not sure, what can you do is whenever you have your answer right now here, you can always expand this back to see if you get back the same value. That's one of the ways to check if you have your right answer or not. Anyways, now let's move on to this one. So hence or otherwise, find the coordinates of the stationary points on the curve. Now, there's always a few methods to find the stationary points, but usually whenever you see hence, just use your previous answer to find that. So right now we have this. We know that the stationary point occurs when this value here equal to 0. So 2x minus 3 has to be 0. X will be 3 over 2, which is 1.5. So x value will be 1.5. And the y value, very simple. It's just the value at the end. So maybe minus 6. So this is your stationary point. By using this answer from part 1, hence we write hence to use this answer to find this answer. Anyways, now for part 3, given that f of x is equal to this, okay, that is the same equation as before, we have to write down the range of f. Now, range of f is always found by observing the graph. For example, This one is pretty simple. It's because we know the graph will look something like this, right? Because the coefficient of x squared is 4, it has to be a minimum curve. We know this is the shape. And we know the point here, it is the minimum point, which means this is 1.5, and the value here is -6. So the range is basically looking at the vertical values. As you can see, the graph is always more than this value. As you can see, from this point on, it always goes up. So we can just write down the range will be f is always going to be more than -6. So here the answer should be f is more or equal to -6, because I did not take into account for that equal. So this is the answer for part 3. This is only 1 mark, supposed to be easy. As you can see, we just use the graph to observe what is the range of that graph. Now let's move on to question number 8. Here we have a curve which is d2y by dx2 is this, given that dy by dx is this, when x is 0, and the curve passes through the point this, we have to find the equation of the curve. Now we have to understand what we are looking for. We are trying to find the equation, which means we are finding the value of y. Now, to find the value of y, we have to know that y is equal to the integration of dy by dx. And dy by dx is equal to the integration of d2y by dx2. So step by step, let's revert everything back to y. So first, let's begin with this. We know that we have to find dy by dx. It is equal to integration of d2y by dx2, which is this, 4 exponential minus 2x dx. That will be, 4 is only a multiple, it will be 4. Exponential, we write the same thing, 2x. Then we have to divide by the differentiation of this term, that should be -2. And then plus c. That will be -2 exponential minus 2x plus c. That is dy by dx. Now we have to find this value of c. So it is given to us that dy by dx is 3, so 3, when the value of x is 0. So replace that in my equation. That will be 2 exponential 0 plus c. From this you will have 3 is equal to -2. This is 1. C, so c will be 5. Because we know that exponential power 0 is 1. So anything power 0 is 1. So that's the main idea here. Okay. So right now we know that we have derived dy by dx as -2 exponential minus 2x plus 5. So let's move forward. We have to find y. Y is integration of dy by dx. So we have to replace this value here. Dx. So what you will have. So we can break it down. As you can see, it is 2 terms. We can of course break it down. Okay, now this will become, here we have -2, -2 doesn't change. Exponential will be exponential power -2. Then divide by the d by dx of this term, that should be -2. And we have to plus, that will be 5x. And of course, plus constant. So we have used c already, let's use d. So y will be this for now. So simplify, this will cancel out. And we have to find the value of d. Now, as you can see, the passing point is this, so we have to use this point to find the value of d. So the passing point is 2, this value. This is my value of x, my value of y. Okay, so we have y is exponential -4, that will be exponential -2 times 2 plus 5 times 2 plus d. So simplify, that will be what? -4 plus 10 plus d. So as you can see, these two will be cancelled out, right? If you send this over here, it will be cancelled out. Now d will be -10. So finally, y, which is the equation of your curve, is exponential -2x plus 5x minus 10. Okay, this is your answer for question number 8. Okay, so let's move on to question number 9. So here we have to find in ascending powers of x the first 3 terms of this expansion. So how can we do this? So of course you can use your formula that is given to you to find that. But we just need to find the first 3 terms. The first term will be power 5, choose 0. That's the first term. We have to choose the first term here is 2. Have minus 3x. So this is 0. This also will be 0. 5 minus 0 is 5. This will be 5. So next one will be 5, choose. After 0 we have 1. This will be 2 minus 3x because 2 is here and here we have minus 3x. Now this is 1. This will be also 1. 5 minus 1 is 4. Next one, 5 choose 2. That will be 2 minus 3x. This is 2. That will be 2. 5 minus 3 is 3. As you can see, we just have to replace those values in our calculators to find the value. That will be 1. That will be what? 2 power 5 is 32. And that will be 1 as well. 5, 2 power 4 should be 16, but let's check. Always double check, you know. You don't want to be making a silly mistake. That will be this, and this will be 10, but let's check. Who knows? Yeah. And this will be 8, and that will be 9x squared. First term will be 32. So 5 times 16 times minus 3, that will be minus 240. And this will be what? 8 times 9 times 10, that should be 720 x squared. As you can see, by looking for the first 3 terms, we have this, this, and this in ascending powers of x. That's great. Now, the first 3 terms of this expansion that we don't know, in ascending powers of x are given by this, this, and this. So by using that, we have to find the values of a, b, and c. So pretty easy. If you observe, what is this? This is from part A. So basically, we have this multiplied by the first 3 terms we have just found from part A. Right. Okay. Now basically, we're just expanding this one right now to find the values of A, B, and C. So one by one. So A times this will be what? 32A minus 240 ax plus 720 ax squared. Now for this one, so plus bx multiplied by this will be plus 32 bx minus 240 bx squared. Of course, we don't need this one because, as you can see, we have no use for the term in plus 720 bx cubed. It's just we have no use for this one. There's no need for this one. So let's see how can we simplify this. So this will be 32a. This will be what? So we can simplify this. Right, plus 32b minus 240 a, factorize x outside. Okay. And then here we can do the same thing. Factorize x squared outside. You will have 720a minus 240b. X squared will be outside. Now we know that this first 3 terms has to equal to this. It is given to us by the question. This is 64. This is minus 192x. And this is plus cx squared. So we just have to compare. As you can see, this must be this must be this, and this must be this. So by comparison, a has to be 2, and this has to be 32b minus 240. A has to be 192. So 32b has to be minus 192 plus 240 times a. A is 2 according to this. So 32b has to be what? Minus 192 plus 240 times 2. That will be 288. Sorry. And divide by 32, that will be 9. So b has to be the value of 9. Okay, so next one here, just replace the values. C is equal to 720a, a is 2, minus 240 times 9. C will be what? So let's solve this. 720 times 2 minus 240 times 9, that will be minus 720. That's a very interesting answer. Let me try again in case I make some mistake. Okay, seems to be right. So this is the three values we need to find for A, B, and C. This is question number 9. Now let's move on to question number 10. So we have two functions, f and g are defined by this. X is any values in the real numbers, so which means it can be any values. Now for part 1, we have to find f g of x, so pretty easy. Basically this is f g of x will be inside of f, which means we have 3 minus x will be g of x. That will be 3 minus x over x plus 2. Okay, that will be your answer for part 1. Now for part 2, hence, so using that answer, find the value of x for which this is true. So we have this here already, which is 3 minus x over x plus 2 has to be 10. So simplify, send this over here and this over here. 3 minus 10 will be minus 7, that will be x over x plus 2. Now cross multiply, you will have to have minus 7x, minus 14 has to be x. Send this over here, let's see what you get. Minus 14, that will be 8x. So finally x has to be minus 14 over 8. Simplify, that will be minus 7 over 4. Okay, that will be question part 2 of 10 or whatever. Now for part B, a function h is defined for the any real numbers of x by this, where x has to be more than 1. Okay. Now part 1, we have to we have to find the range of h. Now sorry about that. To find the range of h, we have to first understand what is the shape of the graph. So basically what we can do here is we can simply do something as just assume the value of x is 1. Let's say for example, right? So you will have h of 1 has to be 4 plus ln of 1, but ln of 1 is 0, that will be 4. So we know that h of 1 is equal to this, which means h of x has to be more than this value. So this is your range, because as you can see, we only take values more than this. So your value of this will always be more than this. That makes sense, right? So the shape will be somewhat like this. Okay, that will be shape of long graphs. So there's only two kind of shapes you need to actually kind of remember, or you can just use table of values as always and find the values one by one. But if you have exponential graphs, for example e of x, the shape will always somewhat look like this. Keeps going up exponentially. And then ln of x, someone looks like this. Always going to be the shape like this. The inverse shape basically, as you can see. Anyways, that's not the main part here. So the main part here is to find the range. Just assume the value of 1, because you can see that's the minimum value that we don't take, right? And then you will have 4. You know that it has to be more than 4. So if it was equal to here, obviously we'll also put equal here, but here we don't have equal. Your answer will be just h, it has to be more than 4. Now for part 2, we have to find this value. So let's first find h inverse. So let h of x equal to y. You will have 4 plus ln of x has to be y. So ln of x has to be y minus 4, and x has to be exponential y minus 4. So finally, from this we can conclude that h inverse of x is exponential x minus 4. But now we have to find of 9, that will be exponential 5 as your answer. Replace x by 9, 9 minus 4 is 5. That will be part 2 of the question. Now for part 3, on the same axis below, sketch the graph of h of x and h inverse of x. So this question it comes out pretty much all the time, right? So the main idea here is, as always, we have to understand that h of x and h inverse of x, they are just reflection of each other in the line y equal to x. So it's always the case, a graph is always a reflection of its inverse in the line y equal to x, of course given that it has an inverse. If it has an inverse, it will always reflect in this line. So again, as you can see, h of x has been given to you by this formula, which is 4 plus ln of x, and h inverse of x is given to you by exponential x minus 4, right? Now you have to begin by drawing the y-axis and the x-axis. Now let's try to find a few values that we can use. For example, let's begin with h of x is equal to 4 plus ln of x. So we know that x has to be beginning where? So we know x is only defined for more than 1. So we know that h of 1 will be more than 4. So let's begin the value here at 1 for h of x. Has to be. So 4 will be somewhere over here, I guess somewhere over here. Let's say over here. So it will not include the value, so we can just make a dot like this to say that the value of 4 is not included, has to be more than 4. Let's mark this as 4 here. And as I've shown you, the graph will have a shape like this. Always keep going up in this direction. Right. Now we have to draw the line here in between them. Make sure you draw a straight line. Use your ruler if you can. And this is, of course, the line y equal to x. So maybe I should have drawn this smaller so we can show a better relationship between those two. And of course, we have to try to make a reflection in this line. So let's see, how can we make a reflection? That will be this somewhere over here. And that should be going up as well in this direction. Now, the question is, do they meet, right? If you want to know, because sometimes, you know, because maybe my graph should have been going up so they can meet somewhere in the line. We can check if you want to. We have, let's see if we can produce a value. So we have 4 plus ln of x. We can equate that to x. So this is hard to solve. I can see, so it's basically not possible here. You guys are not taught how to solve this as of right now, so it will not be possible for you. So right now, as you can see, you will not meet the line itself. I will just leave it as this for your answer. So the main idea is actually to show that it is a reflection in the line y equal to x. This will be, so first draw the h of x that you know, and then reflect this in this, and finally, of course, just label the two so they know exactly which one are you referring to. This is the inverse, and this is h of x. Okay, and that will be your answer for part 3. But as you can see, if you keep going, they will eventually cross this line. That's the idea. Because of the shape of ln of x will be somewhat like this. Keep going on, and exponential will be something like this. So you will always kind of meet in the future somewhere. So if you can draw this one, I think it will be better than this one, because this one doesn't really show that point. They may be looking for that as well. So if you can show that it will eventually meet, it will be better for you. Of course, you have to show this reflection thing, and of course these and these, and label those two to show that. But however, this is kind of tough for you to solve, to confirm on the paper, but by the shape judging itself, you can see that it will go up. This is going down, so they will eventually meet. So please do this one instead. Better for you. And that was question number 10. Now let's move on to question number 11. So here we have to solve the equations between x values of 0 and 180. So step by step and see what we can do. So let's see if we can use something from our list or not. So always check if you have something here that you can use or to see what's possible. So here I don't see anything really. We can just try to simplify. So what is tan 2x? As you know, it is tan 2x. Let's just write it the same, but we know what is cot 2x. It is 3 over tan 2x, because we know that cot 2x is 1 over tan 2x. Okay, so we can just cross multiply to see what happened. That will be tan squared 2x is equal to 3. Okay, so tan 2x can be plus minus root of 3. So for the first value, you can take the positive value, so tan 2x has to be root of 3. Tan 2x has to be minus root of 3. So now we have to solve one by one. So for the first one, as you can see, it is a positive value. It will be in the first quadrant and in the third quadrant. So 2x has to be tan inverse of root 3. 2x will be what? Tan inverse of root 3 will be, so we have to use degrees here. That will be 60 degrees. If it is 60, it can also be the other value. That will be 180 plus 60. That will be 240. Okay? And now for this one, okay, x, obviously, x will be what? X will be 60 divided by 2, that will be 30. And this will be 120. Now for this one, because we have the negative value here, we look at the quadrant again. It will be in this quadrant and in this quadrant. This will be 180 minus theta. This will be 360 minus theta. Now because it is negative, we will first go through the theta route. So theta is not your answer. So tan will be tan inverse of the positive value of root 3. That will be 60 degrees. From this, we have 2x equal to, according to the quadrant, will be 180 minus theta, that will be 120. 360 minus theta, that will be 300. Now x will be 60 and 150. As you can see, you will have 4 values for your answer of x. That will be for part 1. Now for part 2, we have cosec y equal to 1 minus 2 cot square y for this domain. Now go back to your list to see what can you use to solve this one. So here we have something that we can use. Okay, so if you observe, we have seen that cot square y is equal to cosec square y minus 1. Replace back in your equation. You will have cosec y is 1 minus 2 cot square y is cosec square y minus 1. Simplify. Cosec y is 1 minus 2 cosec square y plus 2. Now simplify. Send everything to one side. You will have 2 cosec square y plus cosec y, and then 1 plus 2 is plus 3. So send this over here, become minus 3. Right? Now, as you can see, this one is a quadratic equation. So what can we do is we can try to make our life simpler just by saying this. Let u equal to cosec y. So you will have 2 u squared plus u minus 3 is 0, right? Makes sense? Now we can just factorize. That will be 2u and u. 3 is 3 times 1. To get plus 1, we have to have plus 3 minus 1. So u will be minus 3 over 2. U will be 1. Now again, we're not trying to find the value of u, we're trying to find the value of y. So bring this one back to the main equation. You will have cosec y is minus 3 over 2, and here we have cosec y is 1. Now what is cosec? Cosec is 1 over sine, right? So replace, you will have sin of y is minus 2 over 3, and sin of y is simply 1. So here the value is negative, as you can see. It will be in your third quadrant and your fourth quadrant. That will be 360 minus theta, and this will be 180 plus theta. So here we have to use the root of theta again because it is a negative value. So theta will be sine inverse of the value, positive value. That will be what? Sine inverse 2 over 3 has to be 41.8. Now this is not your answer. Y will be according to your quadrants, will be 180 plus 41.8. That will be 221.8. And then we have 360 minus this one will be 41.8. That will be 318.2. Okay. Now for this one, it is positive, so you will be in your first quadrant and your second quadrant. So here we can find it directly because it is a positive value. That will be sine inverse of 1. That will be 90 degrees. And of course this will be 90. And this will be what? 180 minus 90, which is also 90. So we have only one answer for this part. As you can see, we have this and this and this as your answers. So 3 answers for the value of y for part 2. Now let's move on to the part 3 of this question. We have this equation. We have to solve for the value of z. Okay, so let's see what can we do. So what is sec? Sec is 1 over cos, right? So replace this one here. You will have cos of the angle will be this over 2. Of course, you have to flip this upside down. That will be minus half. Now, when cos is negative, you have to know it will be in this quadrant and in this quadrant. This will be 180 minus theta, and this is 180 plus theta. Okay, so we have again to go through the theta route because the value here is negative. So first step, let's find the value of theta. That will be cos inverse of the positive value. That will be 60 degrees, but let's check. Who knows? Of 0.5, that will be 60 degrees. But here we have to work with radians. Of course, we can just convert. That will be pi over 3. Because something we know is that 180 degrees is pi. We have to know this. So 60 degrees, that will be pi by 3. Okay, so now what can we do? So we know that this is this value. Now we go back to find the real values now. That will be z plus pi by 2. First value will be 180 minus this. That will be 120. Sorry, we have to use radians. I always forget. So that will be 180 is pi. Pi is 1 minus 1 over 3. That will be 2 over 3. And then plus pi, that should be 4 over 3 this. Okay, so let's see what can we do now. So we have to solve for the value of z. So z will be this minus this. So 2 over 3 minus 1 over 2. That will be 1 over 6 pi. And then 4 over 3 minus 1 over 2. That will be 5 over 6 pi radians. We can always check to see if we have any other values, because when this is not z directly, when you have something extra, usually if you have 2z, I recommend adding 360 or 2 pi to each of the values first. But we can check to see if we are missing any values or not. Let's try. So let me add 2 pi to this one. So we have 2 over 3 plus 2. Then minus half, that is too much. Yeah, so anyways, this will be the 2 answers that we need, because we have to look also at the limits here. It is only between 0 and pi. So it is only between 0 and pi for those 2 values of z. That will be your question number 11. Now let's move on to question number 12. A curve have the equation y equal to this. We have to find the coordinates of the stationary points of the curve. So pretty easy. You guys must know by now, whenever we have to find the stationary point, we are trying to find dy by dx is equal to 0. Right, so we have to think about this all the time. Stationary points, which is the minimum and maximum point, we have to think about dy by dx is equal to 0. Now, as you can see, this one is a fraction, so we have to use the quotient rule. So pretty easy. Dy by dx has to be, first write down the denominator as it is, then find d by dx of this one, that will be 2x, then minus, write down the numerator as it is, then d by dx of this one, that should be 1, and everything divided by the square of the denominator. So this one is just a formula you have to know, memorize, or by practice you will memorize it, right? Now simplify. You'll have 2x squared plus 2x minus x squared divided by x plus 1 squared, and that will become x squared plus 2x over x plus 1 squared. Of course, equate that to 0 because we want to find the stationary points. So first thing first, you can just cross multiply. You will have x squared plus 2x is 0. So take x outside, you will have x plus 2, and x has to be 0 and x has to be minus 2. So find the corresponding value of y. That will be 0 over 0 plus 1 is 0, obviously. So here will be 4 over minus 1, that will be minus 4. So y is actually equal to the equation that we have already, which is the curve. So we place this value in here to find these corresponding values. So the points here we have is 0, 0, and here we have minus 2, minus 4. That will be the stationary points. Now let's move on to part 2 of the question. The normal to the curve at the point where x equal to 1, okay, the normal at that point meets the x-axis at point M. The tangent to the curve at the point where x equal to this meets the y-axis at N. Okay, so we have to find a few things. We have to find the point M and the point N, and then find the area of triangle. So one by one. So first, let me write down the equation of the curve, which is y equal to x squared over x plus 1. And we have seen that dy by dx was shown to be the value of x squared plus 2x over x plus 1, this square. Okay, so first thing first, let's just find the values we need. So we need to find this one and this one. So for example, let's say our curve looks like this. We just don't know the shape. Let's say, for example, it looks like this. Now let's say we have a point here, x equal to 1, x equal to 1. So we're trying to find the equation of the normal. So we're trying to find the equation of a line that is perpendicular to that point. This is my normal. Okay, and my normal meets the x-axis, so this is my x-axis at the point M. And we're trying to find this point first. So pretty easy. To find the equation of a straight line, we need to find its gradient. That's the first thing we need to think about. So how do you find the gradient of the normal? So you guys must know by now, the normal is connected to the tangent. So we first find the gradient of the tangent, and this is actually equal to dy by dx. Of course, the point of x is equal to 1 because it's at the point 1. So just replace the value of 1 in here. You will have 1 plus 2 is 3. This will be 1 plus 1 is 2, square will be 4. So gradient of tangent is this. So from this we derive that gradient of normal has to be minus 4 over 3. Okay, so now finally we have to find the equation. So we have to find the passing point. So when x equal to 1, what is the value of y? Replace in your equation. That will be 1 over 2. So y was 0.5. Right, so the passing point, this is the passing point. So the point that it passes was 1 and 0.5. So now we can find the equation of the line. That will be y minus the corresponding value 0.5 over x minus 1 equal to minus 4 over 3. Now cross multiply, you will have 3y minus 1.5 is equal to minus 4x plus 4. 3y is equal to minus 4x plus 5.5. Okay, this is my normal. Now, this is not my answer yet because we have to find the point M. The point M is where they meet at the x-axis. So you have to know, at x-axis, what happens? The value of y has to be 0. Replace y in here, you will have 0 is minus 4x plus 5.5. So x has to be 5.5 divided by 4. That will be 1.375. So the point M has been found to be 1.375 and then 0. That's my first part. Now to find the value of n, the n is a tangent to the curve at the point x equal to minus 2 is this. So again, tangent is a straight line. We have to first find the gradient of tangent at the point x equal to minus 2. So dy by dx, as we guys know, is the gradient of tangent at the point equal to minus 2. That will be what? Replace in your main formula here. That will be 4 minus, that will be minus 4 over something, but here we have 0 already. So we can conclude this is my gradient. Now, the passing point is minus 2, and replace back in my formula, that will be what? So that will be 4 over minus 1. That should be minus 4. Okay, so this is my passing point. Now, if the gradient is 0, you know that your curve has to be what kind of line? No worries, don't think too much. We can just find the equation directly as well. So y minus this corresponding value, so minus minus 4 over x minus minus 2 equal to my gradient. Cross multiply, this will become y plus 4 has to be 0, so y has to be minus 4. So this is my tangent line, and my tangent meets the y-axis at the point N. So what is the point N? So if you think, the point N is simply at the point N, so at the y-axis, we know that x is 0, so it has to be 0, and y is equal to minus 4. So right now we have all the 3 points we need to find our answer, so pretty easy. So we know that M is 1.3750, N is 0 minus 4, and O is just origin. Now if you want to think about the picture itself in your head, we can just draw this just for the sake of trying this in your head. So this will be my graph, for example. This is x, this is y. The first point M will be where? It will be somewhere over here. This will be here, and this will be right here. If you connect the 3 points, what do you have? O, M, N. This is a right angle triangle. And how do you find the area of a triangle which is right angle? Pretty easy. Half times base. The base is this one, which is 1.375, and times height, which is 4. This is 4 here, right? And this will be this value. That should give you what? 2.75 units square. So this is one way of finding the area. You can always just use your formula as usual, which is half modulus starting from the point of M, which is 1.3750, 0 minus 4, the point of N, and then 0, 0, and then ending with the first point, and then just first multiply these, and then multiply these in this direction. You will have 12. So let's try this out. 1.375 times minus 4, that will be this, and then minus, that will be 0, divided by 2. So let's try. So this time this will be what? 1.375 times minus 4 is minus 5.5. Everything else will be 0. Now minus the value of this is 0, 0, 0. Of course, this is modulus here. This will be half. And as you can see, inside the modulus, everything become positive. So 5.5, right? And then divide by 2. That will be 2.75. So 2 methods, you will have to find the same value for those 2. Okay, so this is the last question of this paper. I hope you find this helpful. As always, thank you for watching, and I will see you soon.